Okay guys, I'm going to finish up section 7.4, more stuff about vectors. So we got through example 4 in class today, and what we're going to talk about now is some different vector operations. And so what I have is two vectors up here, and remember I know these are vectors because of these little arrow type of things instead of parentheses. One of the vectors is vector u, one of them is v, and I can actually add them together. I can multiply one of them by a scalar, which is -2 in that case. And I can do both. I can multiply them and, in this case, subtract. So I'm going to show you what that looks like real quick. So for u plus b plus v, all I'm doing is I'm going to use a little bit of notation here. -2 comma 1 plus v is 4, 3. Okay, and so what I'm doing is, this is very simple. You could probably guess what you're going to do, but you're going to take this number and add it to this one. And that gives us 2. Oops. And then I'm also going to take this number and add them together, and that gives us 4. So that is the addition of vector u and v. Okay, so another problem that's pretty similar, I can multiply vector u by -2. It's kind of like distributing. In fact, it's just like distributing. But that's what we get. And then the last one, for u is -2 comma 1 minus 3, v is 4 comma 3. And so 4 times -2 comma 1, that gives us -8 comma 4. And what I like to do, just because it's easy to lose this negative sign, is distribute the negative. So I'm going to change it to a plus, but actually distribute the -3 to both of these, just so you don't lose that negative sign. That's just a little tip for you. So that changes to -12 and -9. And now I just have to add those together. So again, remember, what you're doing is you're taking the -8 and adding the -12 to it, and you're taking the 4 and adding the -9 to it. So that's going to give us an answer of -20 and -5. So pretty simple, but just wanted to briefly show you what that looks like. Let's move on to the next section. Given some ordered pairs, draw the vector through them. And note, really important here, is that this vector starts at A. So the order of the letters, like the way it's written, is important. And it terminates or ends at B. So that is the way that you have to draw your vector, like with the arrow and everything. So I'm going to just get a rough sketch here of ordered pairs. 3 comma 1 is like right here, so there's A. And B is 7 comma 4. -4, excuse me. So here is B. And so to connect those, I'm starting at A and going to B and drawing my arrow right there. So just like in geometry class, it's kind of like array, but in this case it's a vector. So it starts at one point and ends at another one. So that should answer the question of, are these vectors equal? They do have the same magnitude. And remember, magnitude is an important vocab word that we talked about in class today. What it means is length. But they go in opposite directions. Therefore, no, they're not equal. Okay, they do have the same magnitude, however they go in different directions, so those vectors actually look different. BA looks like this. Okay, so going in different directions, so no, they're not the exact same. All right, now you guys, we have this thing called the dot product, and so this is taken right out of your textbook. The dot product of two vectors, it is a formula, and it looks a little bit like weird looking, but I'm going to show you exactly how it works. It's actually very simple. You just need to make sure that you memorize how this actually works. You take this number and multiply them. That's what goes here. And then you take this number and multiply them, and that's what goes here. And you actually add those numbers together. Okay, so really, really simple. It's kind of like a weird distribution type of thing, but 2 times 4 is 8, and 3 times -1 is -3, and when I add those together, I get 5. In this case, the dot product is 5. So it's like a numerical value, okay? It's not like another vector or anything like that. So this one, same thing. 6 times -2 is -12. And then when I do 4 times 3, it's positive 12 equals 0. The dot product is 0, and this is something very important. We have this word called orthogonal vectors, and that means perpendicular. Vectors, and what that, or how you can tell if two vectors are perpendicular without graphing them, is that the dot product equals 0. Yay. Okay, so that is the purpose of having a dot product, is to be able to check to see if vectors are perpendicular without actually graphing them. So just as an FYI, the vector going through 6, 4 looks like this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So I'm going to put a dot there at 6, 4. This is that first vector. And then if I do a different vector at -2, 3, that's right here. That's what that vector looks like. So remember how we practiced drawing vectors today? And doesn't it kind of look like, I mean, I'm not the best artist, but this is a perpendicular angle right here in between those two vectors. And so in order to not have to graph them and like do a really good job graphing, you can do the dot product, which as you can see is a really, really easy calculation to do. And when it equals 0, that tells you that those two vectors are orthogonal, which means perpendicular. It's just a fancy word because it's talking about vectors. Okay. All right, let's move on to, we have just our last couple problems here. And so we have this thing called unit vectors. And this is another thing that you memorize, you guys, and it's almost like kind of silly. You'll get more into this in physics if and when you guys take that class, and for sure if you do some sort of calculus in college, you'll get into unit vectors, or physics in college. But what it is this vector I, and we always use the letter I for this certain unit vector, and the vector is 1, 0. And for j, they always use the letter j. That vector is 0, 1. And those are called unit vectors, kind of like, I don't know, if I could try and parallel it to the unit circle where the radius was 1 all the way around. These vectors both have a unit of 1 in them. How do you remember which one is which? Well, I comes before j in the alphabet, so the 1 goes first for the I and the 1 goes second for the j. So anyways, just remember those, and then it's pretty simple to do practice problems with these unit vectors. So this means that the vector w equals 5 times, well, I is 1, 0, and j is 0, 1. So what I'm doing is I'm filling in this vector for the I, and I'm filling in this vector for the j. And then I know how to combine that. We already practiced that at the beginning of the video, so that gives me a vector of 5, 0, plus, I'm going to change it to a plus negative just so I don't lose that negative, 0, -3. And I also know how to add vectors together. So 5, -3. And this is almost like, why did we just go through that? Because look, 5 becomes the first value and the -3 becomes the second value. It's just practice using those unit vectors and verifying that that's where a vector like this comes from, 5i minus 3j. Let's try another one. This one's going a little bit backwards. Write the vectors in terms of I and j. So what that means is, since the I has the 1 first, I'm going to take this -3 coefficient and multiply it by the I vector. And I'm going to take the 14, which is positive, so I'm going to do plus 14, and multiply it by the j vector. Because it wants me to write in terms of I and j. So this is -3 times I, because remember this vector is just I, and then plus 14j, because the 0, 1 vector is just j. So again, it's pretty simple because this becomes the coefficient of I and this becomes the coefficient of j. So these two questions are just testing you on whether you know what the unit vectors I and j are. Okay, so very last question. We have this formula here. It's like this, or if you want to get the cosine by itself, you can divide these two magnitudes over. This is the same formula, just written with a different variable isolated. But what you need to know is that this is the dot product between two vectors, u and v, so I can find the dot product of these two. And then remember, these absolute value looking things are actually the magnitudes, the lengths that we use Pythagorean theorem for. Okay, so just to give you a sketch of what this question is looking at, if I sketch the vector u, which is 3, 4, that's here. And then if I sketch the vector v, which is 2, 1, that's here. And this question is asking me to find this angle in between them. So that is what this question is asking me, and this is vector u and this is vector v, and we do have a formula for that. So what the formula is I need to find the dot product of u and v, I need to find the magnitude of each of them, and then multiply that by the cosine of theta. Or, since what I want to do here is actually find the angle, I'm going to use this version of the formula and put the dot product on top and multiply the magnitudes and put that on the bottom, and then inverse cos in order to get the theta by itself. Okay, so first thing I'm going to do is find the dot product. So u dot v. Make sure you make a note that that is the dot product, not multiplication. And so remember what that means that I do is I take the 3 and the 2 and multiply them, and then take the 4 and the 1 and multiply them, and then add those numbers together. So 3 times 2 is 6, 4 times 1 is 4. That means my dot product is 10. Second thing I need to do is find the magnitude of each of them. And so remember, it's the Pythagorean theorem type of formula that we practiced in class today. 3 squared plus 4 squared. 16 and 9 is 25. Okay, and then I can also find the magnitude of v. So remember, these aren't absolute values, and we're talking about vectors. This symbol means it means magnitude. So Pythagorean theorem for 2 and 1, that gives me just radical 5. Okay, so now I'm going to use my formula. I'm going to use this one right here, and I'm going to plug in the dot product and the magnitude of u and the magnitude of v. And what that's going to look like is, it says the dot product goes on top, that number was 10, and the magnitude of u was 5, and the magnitude of v was radical 5. So all I need to do there, I can reduce that, I guess, if I want to, change that to 2. You don't have to rationalize if you don't want to. You can, but you're typing this whole thing into the calculator, so it doesn't matter if you rationalize or not. So just make sure in your calculator, I believe when you do square root, it will open up a parentheses for you, so you have to close it. And this is going to give me a theta. Make sure that you are in degree mode because it wants the angle between 0 and 180. That was in that blue box. We get 26.57. Just make sure that you guys are able to type that into the calculator and verify that. But that's kind of the only formula you need to have memorized. They're the same formula, it just depends on what you're given and what you're looking for on how to find stuff. But that concludes the vectors, you guys. Thanks for watching. We're going to practice a bunch of vectors problems in class because it's kind of a lot of little tiny pieces of information spat at you at once. But we're going to practice it in class tomorrow, so bring those questions and get you all a lot more familiar with all the new vocab, okay? Have a good night.